So here we're in the appetizer section. A couple of examples of how to draw a graph of transformations of the parent function. On the left side here we have log base 2 of x, and then we have log base 2 of x plus 3. And we know that that plus 3 value, that's our k. That means we're going to transform, meaning we're going to move the graph of log base 2 of x up 3 units. So let's draw the graph of log base 2 of x. We know that has a key point at 1, 0. Get rid of that. And the key point being at 1, 0, we know that the log graph increases very quickly until it hits the key point, and then it really levels out. That's what we're hoping for the coronavirus, that it finally levels out, and actually we want the coronavirus to go back down. Number of people infected and dying as well. So, but we'll take, like, the coronavirus has been going like that. It's been increasing exponentially up until this point anyway, and we're hoping that it's going to level out more and look more like a log graph, but then again, like I said, go back down. So that being said, that's the original graph. So we have the point 1, 0. If we're going to take this graph and we're going to move it up 3 units, then all we have to do is move that key point up 1, 2, 3. And there's the new key point. It's really hard to draw a dot using this software. Gosh. Okay, so we have the key point now again at 1, 3, and we just draw the graph. Draw the graph through the key point, and that's it. I mean, that's all you really have to do. Now, in saying that, though, you're going to need to be doing some Khan Academy problems here, and sometimes the Khan Academy assignment or problem asks you to plot 2 points. So if you have to plot 2 points here, then you can make an XY chart. First key point, just make the argument equal to 1. All right, so if you make the argument equal to 1, log base 2 of 1 is 0, 0 plus 3 is 3. So that's first, and that's the key point. Whenever you make the argument equal to 1, argument equals 1. And then another point is, if you notice that the base here is 2, just pick an x value so that the argument is a power of 2. And in this case, we can just pick 2. We know that the log base 2 of 2 is 1, and 1 plus 3 is 4. So we have the point 2, 4. 2, 1, 2, 3, 4. And that's a point on the graph. And so that's how you can find 2 points on the graph. And that might be a way that you just decide, I'm just going to do it that way every time. Okay, and in saying that, is harder when you have the log base, oops, didn't mean to do that, the log base e, and if you have log base e, then it's really hard to find a second point, but we can clearly use the same strategies that we've been using to figure out, okay, we know where to find the key point. So the key point is easy to find. So when we graph log base e of x minus 4, we first want to start with, well, let's do that in red this time. What's the, there's a key point right there. On the original graph, log base e is going to look like that. So log base 2, log base 3, you can just draw them all the same, same relative shape. And then anyway, this minus 4 right there, that means the h is 4. That means we're going to go to the left 4 units. First thing you want to do, especially in the cons, is you want to move the vertical asymptote to the left 4 units. So you go 1, 2, 3, 4. So the vertical asymptote now needs to be moved. So in con, you got to move that first before you move any points. So x equals negative 4 is the vertical asymptote. And then if we move the, let's do this, make that a little smaller. But if we move the key point over 1, 2, 3, 4, then we draw the graph, then we're good to go. We'll just draw the graph through that key point of negative 3, 0. And it just looks exactly the same as it did. The original function looks the same way as the transformation, and labeling the key point negative 3, 0. That's it.